Hello, once again, you're welcome back. That's quite an age. We've been looking at the mystified calculus, and this tomorrow we're going to be looking at the application. What is the application of calculus in our day-to-day activity, and also how is it applicable in that the real world in that sense? And I can assure you, just as we're doing, as this is going to be as systematic as possible and definitely robust. I must mention that. Now let's talk about approximation, application to how to use that to find an approximation. And with that, let's look at the problem. Like, suppose we are to compute the, let's say, an approximate value of 9.00, let's say 9000, let's say 5. So we're to compute this value. Now, how do we look at this? Now, recall, we're still looking at function of one variable, y equal to f of x. Remember what we mentioned about the differential rhythm. It's the fact that we want to see how the infinitesimal increment on the input variable, which is your independent variable, how it causes a corresponding increment or changes, let me use that word, on the dependent variable. And we recall our build up. We have this y, we change the y, we have f is x, we change the x. Now let me define a function that handle this. Let y be equal to root of x, and from using this relation we can say let x be equal to 9, and changing x, let it be equal to that 0.0005, which is something as 5 times 10 raised to the power of negative 5. Now with that said, now recall we also derive this, that the y dx is nothing but limits as changing x approaches 0 of the infinitesimal increment on y with that of x. So I can have these to be equal to my dy dx multiplying that changing x. Now look at this. Now back to what we have. If you have y to be equal to root of x, that's same thing as say x raised to the power 1 over 2. Now that dy dx will be equal to, that's 1 over 2 x raised to the power 1 over 2 minus 1, and that will be 1 over 2 x raised to the power negative 1 over 2. Now we have changing y. Now we said x to be 9, so that means that's 1 over 2 and 9 exponential 1 over 2, which is the same thing as 1 over 2 times 1 over 3. That's 1 over 6. Now with that said, now my change of y is the y dx. We say what's that, the y dx? That's 1 over 6. So we have 1 over 6 times changing x. What's changing x? We have 5 times 7 raised to the power of negative 5. So that's 5 over 6 times 10 raised to the power of negative 5. So as such, our function, that's f of x is greater than, so we have y with changing y, we give us an approximate to this, which will be 3 plus 5 over 6 times 10 exponential minus 5. So therefore the root of 9.0005 will be actually going to approximately equal 5 over 6 times 10 exponential minus 5. Now if you have to compute this using a calculator, you're going to find that really this is actually approximately equal to this. We'll continue from there in our next class. Take care.